If you're near a computer right now, just listen for a second. You'll probably hear that gentle whirring sound. That, my friends, is the sound of an unsung hero, the humble computer fan working tirelessly to protect all your expensive electronics from their number one enemy, heat. It's so common we barely even notice it's there.
But have you ever really stopped to think about it? How does this little plastic box with some spinning blades actually do its job? It looks so simple, right? But inside, there's a piece of incredibly elegant engineering. It's basically a marvel of physics hiding in plain sight.
Okay, so let's dive in. To really get it, we're going to do a kind of virtual teardown. We're going to peel back the layers of a standard brushless DC fan and see what really makes it tick. Or, what makes it spin.
So, first things first. Let's imagine we're prying off the fan blade assembly. This is the part we all see, the part that's actually moving the air. But the real magic? It isn't in the blades themselves. It's what's hiding underneath. Once those blades are off, we get to see the motor. This is the core of the whole operation, and it's surprisingly simple. It's really just two main parts working together in a pretty fascinating way.
The first part we're going to look at is the component that actually spins. You can kind of think of it as the fan's heart. And what is it? Well, it's a ring of permanent magnets.
Now, the technical term for this is the rotor. Simple enough, it's the part that rotates. In our fan, the rotor is built right into the hub where the blades attach, and its most important feature is this circular strip of magnetized material. But here's the truly clever bit, how the rotor is moved. It's all done by invisible magnetic forces. It doesn't physically touch the part that drives it. Think about that. No friction, no grinding parts. This elegant, contactless design is the real secret to its incredibly long life. So if the rotor is the heart, then this next part has to be the brain. Fixed right in the center is a small printed circuit board, or PCB. This is the stationary, intelligent part of the whole system. This little green board is where all the electronics live. You've got a control chip, which is like the tiny mastermind of the operation, and then you have several coils of copper wire wrapped around a core. These coils are our electromagnets.
And this brings us to a really key concept, why these fans are called brushless. See, in older motors, little carbon blocks called, you guessed it, brushes, would physically rub against the spinning part to deliver power. It worked, sure, but it created friction, noise, and a lot of wear and tear. Modern fans just get rid of them. They replace those physical brushes with an electronic system of sensors and electromagnets. No contact, no friction, no wear. That is precisely why your computer can run for hours and stay cool and quiet.
Okay, so we have the heart, the spinning permanent magnets, and we have the brain, the stationary circuit board with its electromagnets. So how do they work together? Well, they perform this invisible, super high-speed magnetic dance.
Yeah, this quote just nails it. The whole thing is just a rapid-fire sequence of pushing and pulling, all perfectly orchestrated by that tiny chip on the circuit board. It's a constant, perfectly timed ballet of magnetic fields.
So here's the play-by-play. First, the chip sends a little jolt of power to one of the copper coils, turning it into an electromagnet. This new magnetic field repels one of the permanent magnets on the rotor and attracts the next one, giving the fan a tiny push. The instant that happens, the chip cuts power to that coil and fires up the very next one in the circle, which gives it another tiny push. And this happens over and over and over, thousands of times a minute, creating a smooth, continuous spin.
So now that we've kind of taken it all apart, we can really see why this brushless design isn't just some minor improvement. No, it's a complete game changer for simple motors like this.
By eliminating that physical contact, the benefits are just enormous. You get way higher efficiency because no energy is being wasted as friction. You get incredible longevity because there are no parts to physically wear down. You get that whisper-quiet operation we all love. And because it's all controlled by a microchip, your computer can precisely manage its temperature, spinning the fan faster only when it absolutely needs to.
And when we say longevity, we really mean it. A typical brushless DC fan is rated for over 50,000 hours of operation. To put that in perspective, that's more than 5.5 years of non-stop 24/7 spinning, all thanks to that simple, elegant, contactless design.
It makes you think, doesn't it? The next time you hear that gentle whir coming from your computer, you'll know it's not just a fan. It's a tiny, sophisticated ballet of invisible forces. And it kind of leaves me wondering, what other simple technology that we take for granted every single day is hiding this much clever engineering?